Here's the latest audio research news from the transmitter. International scientific collaboration is more necessary, yet more challenging than ever. By Lucina Q. Uden. International collaboration has given rise to some of the most foundational scientific discoveries. Research conducted on the International Space Station, involving 5 agencies from 15 countries, has led to breakthroughs in fields ranging from medicine to materials science. International collaboration by physicists at the European Organization for Nuclear Research (CERN) enabled the discovery of the Higgs boson, a fundamental particle that gives mass to other particles. In neuroscience, the Enhancing Neuroimaging Genetics through Meta-Analysis Enigma Consortium, involving researchers from nearly 50 countries, has advanced the field of imaging genetics, generating new insights into conditions ranging from autism to frontotemporal dementia. The history of modern science is filled with examples of breakthroughs that have come from the creativity that emerges when global intellectual resources combine. Science is an inherently global enterprise. Though individual laboratories reside in specific countries, the research they conduct and disseminate benefits all of humanity. International collaboration fosters open science and the sharing of resources and expertise. The field of human neuroscience in particular benefits from studies conducted in large, diverse cohorts of people. Such work produces findings that better generalize to the entire global population. For the Enigma study, multinational collaboration was essential for both recruiting the number of participants needed to identify significant links between genetics and imaging data, and for capturing a genetically diverse population. But new mandates in the United States restricting how funds are dispersed to international partners, as well as changing access to databases at the National Institutes of Health (NIH) and travel restrictions, are making this type of collaboration more difficult, putting all these benefits in jeopardy. Over the course of my career, I have worked collaboratively with scientists across the globe. Publications from our group often involve co-authors living and working in Australia, Canada, China, Finland, Germany, India, Iran, Italy, Portugal, Singapore, and Sweden. Whenever our lab has engaged in collaborative projects with international colleagues, the end product has always been more robust. On May 1st, 2025, the NIH announced a new policy that prohibits foreign subawards from being nested under a parent grant. The stated reason is to increase transparency and accountability for funds on foreign subawards in the interest of national security. The plan detailing the proposed new foreign collaboration award structure has not yet been released, but the policy states that the NIH will make awards directly to foreign entities beginning on October 1st, 2025. Because specific instructions on how to structure these applications from foreign entities are not yet available. This news has caused confusion and concern among U.S. scientists and their collaborators around the world. The new policy, in the short term, puts currently funded NIH projects with foreign subawards in a difficult position. Investigators with ongoing collaborations involving subawards to foreign entities have the option to renegotiate with NIH staff to determine whether the work can be done domestically or, if the project is no longer viable without the foreign subaward, terminate the entire project. This policy has potential ramifications for a substantial number of ongoing projects. In 2024, the NIH funded 3,600 subawards totaling more than $400 million to foreign countries. In addition to the new foreign subaward policy, researchers in countries of concern, including China, Cuba, Iran, North Korea, Russia, and Venezuela, are no longer allowed access to several NIH biomedical databases, throwing another wrench in collaborative efforts involving global partners. The NIH is also ending ongoing projects that involve these databases if they also involve institutions in a country of concern. And travel to and from the U.S. for scientific meetings has become more fraught, with cases of academics being detained or deported. A researcher in my own lab who was on a student visa avoided travel to an international conference last month, fearing the possibility of being barred from returning to the U.S. I recently completed a multi-year collaborative research project involving colleagues in Singapore, Canada, Australia, and Germany. As part of the Organization for Human Brain Mapping, an international society dedicated to advancing the understanding of the anatomical and functional organization of the human brain using neuroimaging, we conducted monthly meetings for years to establish best practices for large-scale brain network nomenclature and reporting of research results in network neuroscience. This international collaboration resulted in the creation of a network correspondence toolbox that acts as a decoder for the neuroimaging community to make it easier for researchers to report their findings in a standardized manner. I am in the process of writing an NIH grant to follow up on this project, which includes multiple foreign subawards. The project cannot be completed without the expertise of my colleagues in Canada and Singapore, with whom I developed the conceptual and technical framework for the proposed work. I hope that the new guidelines for foreign components that NIH releases in October will allow for this work to proceed. As our society faces a growing number of existential threats, international scientific collaboration may become more necessary than ever. Global problems, such as climate change and pandemics, require global solutions that don't respect geopolitical boundaries. In neuroscience, large-scale projects such as Enigma are possible only through international participation. The uncertainty and fear that has pervaded the scientific community in reaction to recent developments continues to present a significant challenge to scientific progress. This audio was created using artificial intelligence. Stay up to date with the latest neuroscience news and perspectives at thetransmitter.org. Follow Audio Research News on Spotify, YouTube, or wherever you get your podcasts.